Welcome to The Explainer. Today, we're diving into some fascinating new research that shows how AI could help the entire trucking industry slash its carbon footprint and its costs by up to 40%. And it all comes down to driving smarter, not just harder.
So just think about that for a second. What if we could give every single truck on the road the perfect, most efficient way to drive? That's really the big question at the heart of this study. It's about creating a kind of AI co-pilot. And as you're about to see, the results are, well, they're pretty staggering.
All right, first things first, let's set the stage. You know, heavy-duty trucks are basically the lifeblood of our economy. They move pretty much everything, everywhere. But all that essential work, it comes with a really, really heavy footprint.
And the problem here is really two sides of the same coin. For any transport company, fuel is one of their biggest and most volatile expenses. And for the planet, all that burning fuel pumps out a ton of carbon dioxide. So this is one of those rare situations where what's good for the bottom line is also what's good for the environment.
Now check this out. The data points us to a really clear target. A full life cycle analysis shows that a whopping 70% of a truck's total greenhouse gas emissions happen during the operational phase, when it's actually out there on the road, driving. So that tells researchers exactly where they need to focus, making the drive itself way more efficient.
Okay, so the goal is clear, right? But actually getting there is a lot more complex than it sounds. For years, scientists have been building these models to try and figure out vehicle emissions, but a lot of the traditional methods, they have some pretty serious limitations.
And the difference in the approach here is it's crucial. See, the older models are pretty good at looking back at a trip that's already happened and analyzing it, but they're kind of rigid. They can't really explore all the possibilities to find the absolute best way that trip could have been driven. This new AI approach, though, it's built to do exactly that. It doesn't just analyze the past, it actively searches for the most efficient way forward. Which brings us to the really cool solution proposed in this study, a hybrid AI model. What these researchers did was create an incredibly powerful new tool by combining two totally different but very complementary types of artificial intelligence.
So the first piece of this AI puzzle is something called an artificial neural network, or ANN for short. The easiest way to think of it is like a digital brain. The researchers fed it just a massive amount of data. We're talking over 6 million kilometers of real-world driving information from a fleet of 50 trucks. And the ANN's job was to just pour through all of that data and learn all the incredibly complex patterns between a truck's speed, its cargo weight, and what that means for fuel costs and emissions.
This really lays out the two-step process perfectly. So in step one, you've got the ANN doing all the heavy lifting, all the learning. It creates this super detailed map of all the possible cost outcomes. Then, and this is the cool part, in step two, a second AI system called the genetic algorithm gets to work. Its only job is to be this super fast explorer, and it searches every single nook and cranny of that map to find the absolute lowest point, the one perfect combination of speed and weight that makes costs plummet.
So, after all that work, what did this AI copilot actually find? What does the perfect, most efficient truck trip actually look like according to the data? Well, first off, the model confirms something a lot of professional drivers probably feel in their gut. When you look at speed, there's a really clear U-shaped curve for efficiency. Driving too slow, like being stuck in bumper-to-bumper traffic, is super inefficient. But flooring it on the highway and burning extra fuel is just as bad. The real sweet spot is somewhere right in the middle.
And here it is, the secret sauce. After that genetic algorithm scoured the entire map that the neural network built, it landed on this, the optimal profile. Turns out, the most efficient way to operate is to carry the maximum possible weight. We're talking almost 50 tons at a surprisingly chill average speed, somewhere between 31 and 37 kilometers per hour.
Okay, so we found the sweet spot. That's great. But what does driving in that perfect zone actually mean for a company's bank account and for the environment? This is where the numbers get really, really exciting.
The economic impact is, well, it's just dramatic. Look at this chart. It's comparing the average current cost per hour of a trip with the cost you could get by following the AI's perfect profile. The model shows you could go from $871 all the way down to just $518. That is a massive drop in what it costs to run these trucks.
In fact, when the researchers ran all the different scenarios, the model found a maximum potential cost reduction of 40.5%. Let that sink in. This isn't just a tiny improvement. A savings like that could completely transform how a logistics business operates, making it way more profitable and sustainable.
And this, right here, is maybe the most important point of the whole thing. And this quote from the paper says it perfectly. Because fuel use is tied directly to emissions, every single dollar you save in operating costs is also a win for the environment. Saving money and saving the planet are not fighting each other here. With this model, you get to do both at the exact same time.
So let's wrap it up. The big takeaway is this. Researchers have built this incredible AI that can both predict and optimize trucking costs. It found a very specific sweet spot for weight and speed that can lead to huge savings. We're talking up to 40%, while also cutting down emissions. It's basically a practical, data-driven roadmap to a much greener and much more profitable future.
It's just a powerful reminder that sometimes the solutions to our biggest challenges, like climate change or economic efficiency, don't have to come from brand new engines or revolutionary fuels. Sometimes the answer is just smarter data and more intelligent systems. And it really makes you wonder, what's the next big, complex problem that's just waiting for the right algorithm to come along and solve it?